Imagine looking up at the moon, our closest cosmic neighbor. For billions of years, we believed it was a silent, lifeless rock, dry, airless, and immune to the natural changes we see on Earth. But in 2020, NASA made a discovery that shocked scientists worldwide. The moon is rusting. Yes, you heard that right. Our moon, which should be the last place to form rust, is slowly turning red. But how can rust exist on a world with no oxygen, no rain, and no protective atmosphere? This mystery has left experts puzzled and opened a new chapter in our understanding of the moon and even Earth itself. Today, let's explore this strange phenomenon in detail, the science, the mystery, and what it means for the future of space exploration. Before we dive into the moon's case, let's understand rust itself. Rust forms when iron reacts with oxygen and water. On Earth, this is common. You've seen it on old bridges, ships, or even forgotten tools. Oxygen from the air combines with iron, and with the presence of moisture, it slowly breaks down the metal, turning it into reddish-brown rust. But here's the catch. The moon doesn't have an atmosphere full of oxygen. It doesn't have liquid water flowing across its surface. So in theory, rust shouldn't exist there at all. Yet NASA's data tells us otherwise. The mystery began when NASA's Chandrayaan-1 mission, a collaboration with the Indian Space Research Organization, sent back detailed maps of the moon's surface. The data came from an instrument called the Moon Mineralogy Mapper, or M3. This device was designed to analyze the minerals on the lunar surface by studying the light reflected from them. To everyone's surprise, the M3 data showed signs of hematite, a type of iron oxide. And hematite is nothing but rust. It wasn't just in one spot. The rust was mainly found near the moon's poles, especially on the side that always faces Earth. This raised a big question. Where is the oxygen coming from? And how is rust forming in such an impossible environment? Here's where things get fascinating. Scientists believe that the oxygen needed for rusting doesn't come from the moon at all. It comes from Earth. Our planet is surrounded by a magnetic field that extends far into space, forming a protective bubble called the magnetosphere. Every full moon, when the moon is directly opposite the sun, the magnetosphere stretches out like a tail and actually touches the moon. During this alignment, streams of oxygen from Earth's upper atmosphere can travel along the magnetic tail and reach the lunar surface. This discovery means that Earth and Moon are far more connected than we once thought. For billions of years, Earth's oxygen may have been slowly leaking toward the moon, creating the perfect condition for rust to form, if water is also present. But oxygen alone isn't enough. Rust also requires water. For decades, scientists believed the moon was completely dry. That changed in the late 2000s, when new missions revealed traces of water ice in craters near the lunar poles, regions that never see sunlight. When tiny amounts of this water interact with iron-rich rocks on the surface and oxygen arrives from Earth, rusting can occur. But there's another twist. The moon is constantly bombarded by solar wind from the sun, which carries hydrogen. Hydrogen prevents oxidation. It actually acts like a shield against rust. So in theory, the solar wind should make rusting impossible, yet we see hematite forming. This contradiction has puzzled researchers. One possible explanation is that when the moon passes through Earth's magnetosphere, it not only gains oxygen, but also becomes shielded from most of the solar wind. This creates short periods when rusting can occur. Over billions of years, these rare conditions could explain the presence of hematite today. At first glance, rust on the moon might sound like a small detail, but it's much bigger than that. This discovery challenges our understanding of how planetary bodies interact. It proves that Earth's atmosphere doesn't just protect our planet, it also influences our nearest neighbor. The fact that Earth's oxygen can travel 240,000 miles through space to reach the moon is astonishing. It raises new questions about how interconnected celestial bodies might be. Could our atmosphere affect Mars's moons? Could interactions like this be happening throughout the solar system? For space exploration, this discovery is vital. Understanding how oxygen and water behave on the moon will help future missions, including NASA's Artemis program, which plans to establish a long-term human presence on the lunar surface. If astronauts encounter rusting materials, it may impact the design of habitats, rovers, and mining equipment. The rusting of the moon is not just a scientific curiosity, it's a reminder that the moon is not a static, unchanging rock. For centuries, people thought of the moon as dead and inactive. But discoveries like water ice, shifting lunar soil and now rust prove that it is evolving in ways we are only beginning to understand. The rust also hints at the moon's history. By studying hematite deposits, scientists can trace back how long oxygen has been reaching the moon and how much water may have existed in the past. This could give us clues about Earth's early atmosphere and even the origins of life. NASA and other space agencies are now planning missions to investigate this phenomenon further. Future lunar landers may carry instruments designed to directly study rust on the moon's surface. Samples collected could confirm whether the hematite truly formed from Earth's oxygen, or if there are other unknown processes at work. Some scientists even speculate that micrometeorite impacts may play a role. These tiny space rocks can deliver both energy and small amounts of water, creating the right conditions for rust to form in bursts. If this is true, then rust might not be unique to the moon. It could exist on other airless bodies like asteroids. So, the next time you look up at the moon, remember this. Our silent companion is not just reflecting sunlight, it's holding on to secrets written in rust. A process that should be impossible is happening right above our heads, linking Earth and Moon in a chemical dance across space. Rust on the moon challenges everything we thought we knew about planetary science. It proves that even in the harshest environments, change is possible when elements align just right. And as we prepare to return to the moon with astronauts and build new lunar bases, this discovery will shape how we explore, how we build, and how we understand our place in the universe. The moon is rusting, and in that rust lies a story of connection, mystery, and the endless surprises waiting for us in the cosmos.